We're going to be looking at slant asymptotes today. I chose to do slant asymptotes in a separate video because we have a vertical and horizontal which occur most frequently, and then every now and then you'll have a slant asymptote. So since they occur only every now and then, I thought I'll do them separate. So here we go. They occur when we have some sort of rational expression, of course, because that's what we're doing, and when the denominator must be of degree greater than 1, and the numerator is of degree exactly 1 more than our denominator. So let's look at one. Here's a picture of a slant asymptote, and you can see that my slant asymptote occurs right along this line right here. And we've got to figure out what that line is, and our function approaches that line as x travels towards infinity and negative infinity, and that'll be the case in our slant asymptotes. Here's our example. We're going to look at the quantity x squared minus x divided by the quantity x plus 1. The first thing that you'll need to do is your division. So you will do your division as we discussed in a previous video. And I've already done the division for you. So when you do the division, you will get that f of x equals x minus 2 plus 2 over x plus 1. Now the part that you're concerned about is this guy right here, because this will be the slant asymptote that your function follows. So if you will put that in to your graph as a dotted line, this x minus 2 quantity, and let's look at our function that we had our graph up of, because this is the one that I actually drew. If I were to draw a line that was x minus 2, here would be his y-intercept, and it would be a line, and I could dash this line all the way up and down through here, and you would see that I have a slope of 1, and it hits the y-axis there at negative 2, inside graphed x minus 2. The next one I've graphed for you is x cubed divided by the quantity x squared minus 4, so we could see one that's a little bit different. When we do his division, which we'll look at in just a second, we will see that his slant asymptote occurs at y equal x. So if you look at this y equal x line along through here, you'll see that as x approaches infinity and negative infinity, our function is approaching that line. Alright, here's the algebra of that function in finding the slant asymptote. I have my f of x equal x cubed over x squared minus 4. When you do that division, you will get that f of x equals x plus 4x over x squared minus 4. Once again, this quantity here is going to be your slant asymptote, which was what we saw on our graph. And just to take note, I want you to notice that the degree of the numerator is a 3, the degree of the denominator is a 2. Therefore, I knew it had a slant asymptote, and that's your test to determine whether or not something has a slant asymptote. And then you will use this quantity here, the part that's not the remainder, you'll use that quantity to determine what your slant asymptote is. And you'll just draw that in your graph as a dash, and then you'll make your function approach that in what we call the ends or the tails of the function. And that's all there is to slant asymptotes. Good luck.